This call is now being recorded.
Okay. So today we'll start with the next recording techniques. So the name of the recording technique is the cycle graph and the chronocycle graph. Okay. So before starting this particular new method, so whatever we have covered in the last lecture related to the diagrams. So last lecture we have discussed about the string diagram. So it is one of the type of diagram which is used in order to track the movements of the operator or the movements of the material when it is moving from one machine to the another machine, and what are the advantages of that particular string diagram over the flow diagram. That advantages also we have discussed in the yesterday's lecture or in the previous lecture. So whatever the disadvantages are there for the charts, that disadvantages can be eliminated by using the diagrams. In that diagram, again, it is divided into the two types, flow diagram and the string diagram. But in case of a flow diagram, whatever the critical movements are taking place, whatever the critical backtrackings are taking place, it cannot be recorded by using that particular flow diagram. Therefore, that limitations can be eliminated by using the string diagram, in which we are taking that particular string. Then pins we are taking, that pins we are keeping on that particular board, whatever the white board we have selected for the demonstration purpose, and on that particular board you are having your layout of your plant, in which all the machines or all the workstations are to be recorded. And by using that particular string, we can measure the actual distance traveled by the material or the actual distance traveled by that particular operator. So through this particular string diagram, you can identify the critical movements or the critical paths. In addition to that, whatever the number of backtracking is taking place from 1 to 4, 4 to 1, again from 4 to 1, again from 1 to 4. So such types of the backtrackings can be recorded by using that particular string diagram. Okay, so this is the second recording technique. After that, we have discussed about the templates. So what is meant by the templates? It is simple related to your colored papers. So whatever the color sheets are available, maybe white color, black color, yellow color, green color. So such types of the color sheets are available in case of a template, and that color sheets or that particular color codes are used in order to indicate all the facilities in the industry. Maybe if I have to indicate the number of operations, so that operations can be represented by using the different color. If I have to indicate or if I have to segregate the drilling machines, CNC machines, lathe machines, so such types of all types of the machines, one color code will be given. Also, if I have to indicate the number of operations which I am going to perform, means initially I will perform the operation, then I will go for the inspection. Then after that, your material will be moved to the one machine to the another machine. That means transportation is taking place. In between that, if your tool will get break, if I have to change the coolant, so like that, the delay happening in the operation, it is also recorded by using the different color sheets. So in order to indicate such types of the important things or all the facilities in the organization, we are using the templates. So the template simply says that the different types of the color papers which are used for the demonstration purpose. But that method is very less expensive, no problem. But whatever the non-scalar operators are available, to that particular non-scalar operator, such types of the colors are not possible to identify, because they are unaware about the color coding. For example, the blue color will be applicable for the lathe machine, yellow color will be applicable for the CNC machine. So such types of the indication, first of all, we have to give to the unskilled operator. Then and then only they can identify that this color will be applicable for this, and now this color is in front of you, we have to perform this particular task. So such types of the color codings can be indicated by using the template. Then next we have discussed about the models. The models means which is used for the demonstration purpose. So we can prepare that particular model either by using the wood or the plastic, and that particular models we can use for the demonstration purpose. So through this particular model, if we will explain the things to the unskilled operators, at that time he can get the idea immediately. But if I will explain the things only by in the descriptive manner, so at that time that unskilled operator will unaware about that particular machine or how the power transmission is taking place or what are the important parts. So for that purpose, initially we can prepare the models by using the woods or the plastics, and by using that particular models we can give the demonstration. Okay, so that models also we have discussed in the last lecture. Now today we'll discuss about the next important techniques, which is called as a cycle graph and the chronocycle graph. So this is also one of the techniques which is used to track the movements. But the cycle graph and the chronocycle graph, it is It is one of the technology which is developed by the scientist who is called as a Gilbert. So the Gilbert is one of the scientists who has developed the concept of the industrial engineering, and in addition to that, he has developed this particular techniques which is called as a cycle graph and the chronocycle graph. So this particular method is especially used for the movements which are too fast. For example, if I am taking my particular hand from left to right direction within fraction of second, so such types of the fast movement, it can be recorded by using this particular cycle graph and the chronocycle graph. So that particular movement, it can be traced by using the human eye only. So for example, if I am taking or if I am operating the machine by using the left hand, and from the left direction my hand is moving to the right side within fraction of second. So that particular fast movement, it can be recorded by using the human eye only. So such types of the movements can be recorded which are taking or which are moving very fastly. Such types of the fast movements can be recorded or it can be traced by using this particular cycle graph, and second one is a chronocycle graph. Therefore, this particular method is very accurate and it records the minor details also. So this particular method is very accurate. This cycle graph and the chronocycle graph, it will not be used to track the movements. For example, your material is moving from machine 1 to 2, 2 to 3, 3 to 4, or the operator is moving from one workstation to the second, second to third, third to fourth. So this particular long distances, it cannot be measured by using this particular cycle graph and the chronocycle graph. If the operator is operating any machine, it may be lathe machine, it may be the drilling machine, it may be the CNC, it may be the VMC. So in the single machine only, whatever the small movements he is performing to start the machine, to change the tool, to change the coolant. So whatever the small movements are taking place within fraction of second or within small period. So such types of the small movements, minor movements we can say, that can be recorded by using this particular cycle graph. So this particular method is very accurate as compared to the flow diagram or as compared to the various types of the charts. Therefore, furtherly, here, these particular graphs are divided into the two types. So the first one is a cycle graph and second one is a chronocycle graph. So in this particular techniques, so what we are using small electric bulb. Now, for example, if your right hand is working on any type of machine, or maybe if your left hand is working on any type of machine, maybe the left hand is used for holding the tool, another right hand is used to start the machine, again your right hand is moving the another type of the operation, then your left hand is moving to start the machine. So that means simultaneously the right hand is also working, left hand is also working, but their movements are in only small region only. In that particular machine only your movements are taking place, and if I have to record that particular movement in the until the minor movements are taking place. So for that purpose, in case of a cycle graph, what we are using the electric bulb. We know about the electric bulb means small LED bulbs are there which are used for the demonstration purpose. So that particular electric bulb I can attach to the finger of that particular human or the operator. So for example, if my right hand is in a working condition, so what I will do, I will attach one electric bulb to my one of the finger of the right hand. If my left hand is also working, so the second electric bulb I will attach to the left hand also, and whatever the movements are taking place, maybe your left hand is moving from left to right direction to start the machine, your right hand is moving to hold your job into that particular job, then my right hand is moving towards the button to start that particular machine. So whatever these particular small movements are happening, that small movements can be recorded by using this particular electric bulb. So what happens if the movements are going on, maybe from left to right direction, from top to bottom, maybe some of the movements are taking place in the inclined direction. So all those particular movements can be recorded by using that particular electric bulb and one of the camera. So in this particular technique, the two important devices we have to use in order to track the movements. That is, first one is the electric bulb, which is attached to the fingers of the right hand and the left hand, and one camera is used. That means whatever the operations we are doing in that particular machine or on that particular workstation, near to that particular workstation we can attach one camera, and if through this particular camera we can observe the movements taking place by that particular electric bulb. through this particular camera, we can observe the movements taking place by that particular electric bulb. One electric bulb is attached to the left hand. So along with that particular hand or along with that particular finger, that bulb is also moving from left to right direction, from top to bottom, or from bottom to top, or maybe some inclined direction. So that each and every movement, it can be recorded by using that particular camera. Similarly, another LED bulb is connected to the right hand. So along with that particular right hand or along with that particular finger, that right hand or that bulb is also moving from left to right or right to left, top to bottom or bottom to top, or maybe some inclined positions are there. So all that particular movements performed by the right hand, it can be recorded by using that particular camera. That means that camera will trace out the movements taking place by that particular electric bulb, and that movement can be indicated by using this particular cycle graph, and second one is a chronocycle graph. So if you look at to the first figure number 1, so what that particular figure indicates, it indicates a one graph. You can see here this particular black lines are there, maybe some inclined position. So this particular black line represents the one of the graph, means whatever the movements are taking place, maybe by the left hand or maybe by the right hand, that particular movements are recorded or it is traced by using the camera. Now, for example, this is your starting point at the bottom side. This is the starting point. Let us consider this is the point number A, and this is your end point. Let us consider this is the point number B. So now let us assume that this particular graph will be applicable for the right hand. So initially the position of the right hand is at point A. The electric bulb is attached to it. The camera is going on. If you start doing the operation, maybe from point A, your operation is start. So your right hand is moving towards the machine chuck in order to hold the job. Again, it will move towards to fix that particular tool. Again, it will be moved towards button in order to start the machine. Again, once the operation is over, again your hand is moving to that particular chuck in order to remove that particular job. And once the job is removed, we can keep that particular job in one of the tray. So whatever the movements are taking place to convert the raw material into the finished goods, all that particular movements can be recorded in that particular camera. Why? Because to that particular right hand or one of the finger of the right hand, that electric bulb is attached, and that electric bulb is always in starting condition. Okay, once your movement is start, that electric bulb is also moving along with that particular right hand, and wherever that bulb is moving, that movements can be traced by using that particular camera, and finally the output of that particular camera, it can be represented in this particular graph. So whatever this particular dark black line is represents, this particular line represents the path, or it will represent the direction of your hand. Maybe your right hand is there or maybe your left hand is there. So whatever the small movements are taking place within short period or within the very small period, but they are taking in very fast manner. So such types of the small movements or minor details, it can be recorded by using this particular cycle graph. So whatever the instruments we are using, maybe the electric bulb or maybe the camera, these are the two important instruments which are plays very important role in this particular cycle graph and the chronocycle graph. So in case of that particular flow diagram or in case of a string diagram, so such types of devices are not used. So in that, maybe that string is used, or maybe that operator or that material is traveling from one station to the another station, then directly we can measure the distance. Then from 2 to 3, again directly we can measure the distance. So directly we can measure the distances by using that particular all the types of diagrams. But in case of this particular cycle graph or maybe in the chronocycle graph, whatever the small movements are taking place, which are very fast, that can be traced by using the human eyes only. So whatever that particular small movements are taking place, that can be traced by using the human eyes only. Therefore, we are using the special cameras in order to trace that particular movements. Therefore, if only electric bulb is available and we are observing that particular all the movements by using the human eye only, it is not possible to track all the movements. Or by using the single camera only without attaching that particular bulb to one of the finger, it is not possible to obtain the movements. So along with bulb and along with the camera, we have to trace out all the small movements, and after that, that particular movements can be indicated by using this particular graph. So the first figure indicates the graph is applicable for the cycle graph, but through this particular cycle graph, you will not get the direction from which direction to which direction your hand is moving. Maybe it is moving from left to right, or whether it is moving from right to left, or whether it is moving from top to bottom, or whatever the work you are doing. Sometimes in between, if you are performing some of the work, in between sometimes the speed of your work is decreases. Maybe your hand is moving in very small speed. Sometimes in order to perform the work immediately, speed of your work is also increases. Speed of work is increases means whatever the movements are taking place by that particular hand. Sometimes that movement is increases, its speed is increases, sometimes its speed is decreases. So that particular direction of that particular hand, then whether speed is increases or whether speed is decreases, that information you will not get from this particular first graph, that is cycle graph. So to avoid such types of the limitation, the second graph is developed, which is called as a chronocycle. In that particular chronocycle, you will get all the types of information. That means where your hand is moving, whether it is moving from left to right, or right to left, or top to bottom, or in between, whether the speed of your hand is increases or the speed of your hand is decreases. That is also recorded by using this particular chronocycle graph. Therefore, if you identify the difference between the first graph and the second graph, in the first graph, the movement is recorded by using the single dark line only. But in case of a chronocycle graph, this particular movements can be recorded by using the pear-shaped dots. So what if this particular dots are there? So this is the dot number 1, this is the dot number 2, this is the dot number 3. So these particular dots are called as a pear-shaped dots. So such types of the pear-shaped dots you will get in this particular chronocycle graph, but that particular dot is having some of the important things. So whatever this particular pointed ends are present, you can see how the graph is looking. At this particular bottom side, it is circular in cross section, but at another side, it is in the pointed region. So at one side, the circular section is there, at another side, its one end is represented in the form of pointed end. So that pointed end is having some of the meanings. Also, the gap between dot number 1 and dot number 2, it is also having some of the meanings. So whatever the things are not possible by using the cycle graph, maybe the direction of movement, speed increases or decreases, that all that particular limitations, it can be eliminated by using this particular chronocycle graph. In chronocycle graph also, again we are using that particular LED bulbs, again we are using the cameras, but it is the advanced technique as compared to the cycle graph, in which again we are attaching that particular LED to that particular hand, and we are observing that particular movement of the LED or the movement of that particular hand by using the camera. But whatever the output you will get, it will be not in the continuous line only. That output will be obtained in case of a chronocycle graph in the form of a pear-shaped dots. So these particular dots are called as a pear-shaped dots, and that particular dots are having pointed end. You can see at each and every dot, it is having the pointed end. That pointed end represents the direction of movement. You can see here. For example, this is the dot number 1. It is having the pointed end here. It is having the pointed end here. This is the third. It is having the pointed end. For each and every dot, it is having the pointed end, means it represents the direction of movement. So for this particular figure, it is started from the left side. It is moving to the upper direction. It is moving to the upper direction. It is again moving to the right side, but it is in the downward direction. So through this particular pointed end of the pear dots, we can easily identify that in which direction movements are taking place. That means one information you will get which is not got from the cycle graph. In the cycle graph, we don't have any idea whether it is moving from left to right or right to left, or from bottom to top or top to bottom. But from this particular pointed end of the pear-shaped dots, I can easily say that it is moving from the left direction to the right direction. Initially, it will be move in a upward direction. Along with upward direction, it will be start moving in the downward direction towards the right side. Means all the pointed ends are moving towards the right direction. That means here I can say that whatever the movement is taking place, it is taking place from the left to right side. In addition to that, whatever the gaps are present in between two dots, So for in between each and every dot, some gap is present. All the dots are not connected to each other. So some gaps are present. If I will maintain that particular gap as a common, or if the constant gap is there in between this particular two dots, means you are working with the constant speed. You are working with the constant speed. If there is a maximum gap is present between the two dots, means we can say that the speed of your working or the speed of your movement is goes on decreasing. Therefore, here you can see this is one dot is there and this is the second dot is there. Again, this is third dot is there. So in between this particular two dots, the maximum distance is present. So in between this particular two dots, the maximum distance is present. That means at this particular moment, the speed of working is decreases. Again, from this to this, again, somewhat gap is there. So that maximum gap represents the speed of that particular movement is goes on decreases. But whatever the dots are present to the left side, maybe at this particular left side, some constant distance is mentioned in between all the dots. So that constant distance represents the speed of working is to be constant, or maybe sometimes the speed of that particular movement or the speed of that particular your hand is also increases. Therefore, from this particular chronocycle graph, you will get the information about the direction of movement, where it is moving, and along with the gap between the two dots, it will give the information about whether speed of the movement is increases or the speed of the movement is decreases. So such types of the information you will not get from the cycle graph, because in the cycle graph you will get the output in the form of only dark lines. So if you go through this particular graph of the cycle graph, you will get only dark lines. Okay, but from this particular dark line you cannot say that whether it is moving from left to right direction or right to left direction. In addition to that, whether your speed of the working is increases or whether your speed of working is decreases, such types of the information you will not get from this particular cycle graph. So to avoid such types of the limitations, one advanced version is developed by this particular cycle graph, and that particular new version is called as a chronocycle graph. In both the methods, we are using the LED bulbs which are attached to the each hand or finger of the hand. In addition to that, the camera is provided near to that particular workstation in order to go for the observation. So whatever the movements are taking place, maybe in the cycle graph or maybe in the chronocycle graph, all that particular movements can be traced by observing that particular movement through the camera. And from that particular camera, you will get the output in the form of such types of the graphs. So in the cycle graph, only single line is there, but in case of a chronocycle graph, you will get the output in the form of pear-shaped dots. But that each and every dot is having meaning, whatever I have discussed just now. That is, the pointed end of that particular dot represents the direction of movement, maybe from left to right or from bottom to top, and the gap between these two dots represents whether your speed is increases or working speed is decreases. So such types of the small movements, it can be recorded or it can be tracked by using this particular cycle graph and the chronocycle graph. If I have to trace out the movement for the each and every workstation, so for each and every workstation we have to provide the separate facility. Maybe the separate camera is provided to the each and every workstation. Separate LED bulbs are provided to that particular each and every station. So wherever your operators are working in a single machine, at that time, that movements are taking place by that particular operator on the same machine, but that movements are in very small movements, or whatever the minor movements are taking place, that minor movements are only recorded by using this particular cycle graph and the chronocycle graph. So if you take the example of the lathe machine, while working on the lathe machine, simultaneously the small movements are taking place. Maybe sometimes your left hand is moving towards the chuck, right hand is moving towards the tailstock, then right hand is moving for holding the tools, then your left hand is moving to rotate that particular wheel, maybe in clockwise direction or maybe in anti-clockwise direction. Sometimes your hand will be moved in order to change the speed. So whatever this particular small movements are taking place on the single machine only, all such types of the small movements can be recorded by using this particular cycle graph and the chronocycle graph. So, and after that, if we will analyze this particular graph, maybe cycle graph and the chronocycle graph, wherever the speed is decreases or wherever the speed is increases, we will go the detailed study about that, and wherever some unnecessary small movements are taking place, it is not required, but unnecessarily that small movements are taking place, that small movements can be eliminated afterwards. Then we can work in the effective manner and your work will be completed in within time. So in order to record that particular small movements on the single machine, the cycle graphs and the chronocycle graphs, this recording technique is developed. So initially the cycle graphs are developed, but it is having some limitations. To avoid that particular limitation, the second method is developed, which is called as a chronocycle graphs. So this is about the next recording techniques which are used to track these small movements by using the human eyes. And this method is very, very accurate because we are observing the things by the human eyes only. So whatever the movements are taking place, that movements we are observing through the human eyes only or by using the high definition cameras. So whatever the information you will get through this particular technique, that information is very accurate. So this is one of the next techniques which is called as a cycle graph and the chronocycle graph. Okay. Now I will discuss about the next concept which is called as a micro motion study. So the name itself suggests that the micro motion study means study of small motions known as a Therblichs. So Therblichs means there are some standard symbols. There are some standard symbols are there. By using that particular symbols, we can go for the concept of the micro motion study. That means whatever the small movements are taking place, maybe we are holding the job, we are searching the job, we are looking towards that particular job, we are holding the tool. So whatever that particular small movements are taking place, for each and every moment, the symbol is defined. For example, if I have to hold the job, for holding separate symbol is there. If I have to search that particular job, or if I have to go for any type of operation, that operation can be represented by using the another types of symbols. In addition to that, if I have to transport the job from one location to the another location, that transportation or that moving, it can be represented by this particular another symbol. If I have to go for the assembly of two components, that assembly, it can be represented by using the separate symbol. Again, disassembly is there. If I have to go for the inspection, if I have to release the load, once your operation is over, and if I have to release that particular job from that particular machine, for releasing that, again the separate symbol is there. If I have to keep the component at one constant position, at the rest position, again the separate symbols are there. So that all that particular symbols are called as a Therblichs. Therefore, in case of a micro motion study, whatever the small motions are taking place while doing the operations, here I am not thinking about the big distances traveled by that operator or by that particular material. That big distances travel, it can be calculated by using the flow diagram or either by using the string diagram. But whatever the small motions are taking place, that small motions can be recorded by using this particular micro motion study. But here we have to follow some of the standard procedure. Through that particular procedure only, we can go for the study of this particular micro motion concept. So here, each human activity can be divided into the number of small activity. This is the first requirement of the motion study. So whatever the single activity we are performing, single activity in the sense, for example, if you take the example of the drilling machine. Now, if we have to go for the drilling operation, so initially what we will do, we can take that particular component in one of the hand. That component we can hold on the drilling machine. We can hold that particular job in one of the chuck or one of the fixture. Then we can take that particular drilling tool towards that particular job. We are performing the drilling operation. Once the operation is over, that tool, it can be regained to its original position. Again, we can take that particular finished job and we can keep at this particular position. So this is the one task. Which is our task? We have to go for the drilling operation. So this is one activity. This is the one human activity. So that particular activity we can divide into the number of small activities. Number of small activity in the sense, first activity is holding the job. Second activity is start the machine. Third activity is take the tool towards that particular job. Next activity is perform the drilling operation. Again, next activity, that drilling tool, we have to keep their original position. Next activity, we have to release that particular job. So single drilling operation, in order to perform the single drilling operation, number of activities we are performing. And that activities dividing means we can divide the human activity into the number of small activities. Then the purpose of such study is to obtain the best pattern of movement which takes place the less time and fatigue less to complete that particular task. So what is the purpose? What is the use of that particular activity that we have to divide into the number of small parts? So due to that particular dividing that elements or dividing that particular activities in number of small activities, you will get the best method. If I will divide that particular work into number of activities and if I will go for the detailed analysis. So through this particular division, you will get the best method or best techniques through which whatever your time is required to perform that particular operation, that time will be reduced. Also, while performing that particular operation, whatever the fatigues are taking place to that particular operator, sometimes while performing the drilling operation, that operator is in fatigue. He is not in a position to work on that particular machine. Maybe that machine, it is under the maintenance. So such types of the disturbances are arising while performing the operation. Therefore, whatever the activity we have to perform, we have to divide that particular activity into the number of small activity, due to which you will get the best method, and to that particular best method, the less time is required to perform the operation, and while performing the operation, there should be the less fatigue. If operator is working on the machine without any fatigue, then only whatever the time is required, it is very less. If he is working on that particular machine with the number of fatigues, so he cannot work in the effective manner. If he is not working in the effective manner, automatically your production time is increases and your production cost is increases. Therefore, dividing the activities is very important. Then the micro motion study involves taking the motion picture of the activity of an operator along with the timing devices. In the micro motion study, what we have to do, whatever the activities we are performing, for example, taking the job from one location and holding on the machine. So this activity we are performing, we have to take the motion picture. We have to take the motion picture of that particular activity. That means taking the job from one location and holding on the machine. So whatever this particular movement is taking place, that movement we have to record. And that particular concept is called as a motion picture. Don't take only picture. We have to take the motion picture. So whatever the movement is taking place from one location to the another location, that movements we have recorded, that particular concept is called as a motion picture. So whatever the number of activities we are performing, for example, taking the job from one location, holding on the machine, this is the one movement. Then start the machine, this is the second movement. Third, take that particular tools near to that particular job to perform the operation, this is the third movement. That movements also we have to record by using the cameras, and that particular movements are called as a motion pictures. That motion pictures we have to record while performing each and every activity along with the timing devices. So if I have to take the component from one location and I have to hold on that particular component on the machine, how much amount of time is required to take that particular component from one location and hold on the job. So along with taking that particular picture, we have to focus on that particular time also. If I have to take that particular tool near to the job, means we are performing one activity. So that activity is also recorded by using the camera, but during that, how much amount of time is required to take that particular tool near to your job. That means along with that particular motion picture, along with that particular movement, we have to record the time required to perform that particular activity. So from the starting point to the end point, whatever the number of activities we are performing, maybe operator is performing, all that particular activities can be recorded in the form of motion picture. During that particular recording, we have to measure the time required to the each and every activity. For example, we are performing a drilling operation, and the drilling operation is further divided into the 5 activities. That means 5 times we have to go for the movement. So all that particular 5 movements are recorded in one of the camera in the form of motion picture, and for each and every activity we have to measure the time by using the timing devices. And once all the recording is done, all the time is recorded, what we have done, later on here, the film is steady by running it slowly on the projector. So whatever the each and every moments we have recorded, we have to play that particular moment by using the projector, and through that you have to go for the frame by frame analysis. For example, activity number 1. If I will play that particular activity number 1, we have to go for the detailed analysis. Which are the drawbacks for the activity number 1? Which are the drawbacks for the activity number 1? If that activity number 1 is taking the maximum time as per the requirement, so that particular time required to perform that particular activity, then the fatigue is required or fatigue arises to perform that particular activity. All such types of the detailed analysis will be carried out by running that particular activity number 1 by using the projector. That means simply we have to play that particular video. So whatever the movements are recorded by using that particular camera, we have to open that particular video on one of the big projector and we have to start it. That means that particular whatever the recording is done, that recording is playing, and through that particular playing you have to observe that particular each and every activity frame to frame, and if any changes are required in that particular moment, we can note down all that particular changes, and during that particular analysis, whatever the problems you are arises, that problems you have to go for the analysis, and then afterwards we can go for the further modification. That means if you take the example of maybe films, whatever the films we are recording, so what we are taking, we are recording each and every separate activity. Maybe one recording is taking place at one place, another recording is taking place at another place, third recording is taking place at another place, one more recording is taking place at one of the home, another recording is taking place at the garden. So what we are doing, we are record each and every activity at the different locations, and at the end what we are doing, we can combine that particular activity. Activity number 1 is combined with 2, 2 is combined with 3, 3 is combined with the 4. Like that, we are preparing the film. Similarly, here also, whatever the operation we are performing on any type of machine, to perform that particular operation, whatever the number of activities we are doing, that each and every activity we have to record it along with time, and at the end, we have to combine all that particular activities and we have to prepare one film. And that film we have to play on the projector, and once it is playing, we have to observe it in the detailed manner. We have to go for the detailed analysis, and from that particular detailed analysis we have to identify that whether any problem is there or not. If any problems are there, we can note down that particular problems, and next time if we are performing the same activity, at that time we can eliminate that particular unnecessary activities. Therefore you can complete your work in less time and in the less fatigue. So this is the concept of the micro motion study. That means we have to record the activity. Each and every activity you have to record in the form of motion picture. Means we are recording the video. Whatever the activities we are performing, we are recording that particular video. At the end, we can combine all the videos in the sequence, proper sequence. 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, like that. We can combine all the videos and we can prepare one film. And after that we can go for the analysis of that particular film. If any drawbacks are there, we can eliminate that particular drawback, and next time we can work in the effective manner. So this particular concept is called as a micro motion study, and these are the 3 steps which we have to involve in this particular micro motion study. What is the first step? Filming the operations to be studied. Means the microchronometer is a timing device. It's kept in the field view while filming. The microchronometer is one of the device. If you take the example of stopwatch, the stopwatch is available in our mobile phones. Similar to that particular stopwatch, in industry, this microchronometer device is used. It is very sensitive device. This microchronometer timing device, it is used for measuring the timing. So while filming, while recording that particular movements, once your recording is start, you have to start this particular timing device also. If the first activity is taking the 5 minutes, so you have to take that particular video for the 5 minutes continuously. Once your operation is over, you have to stop that particular timing device. Means along with that particular video, you will get the time required to perform that particular operation, and that time can be recorded by using this particular micro chronometer. That means first step is filing the operation to be studied. Which types of the operation we have to study? Which types of the task we have to go for the study? That study first of all we have to decide. Then analysis of data. It includes selecting typical work cycles. Film is running slowly. It is usually stopped or reversed frequently to identify the motion. So wherever the critical movements are taking place, wherever the typical work cycles are there, for that critical activities only, we have to apply the concept of micro motion study. If the movements are very small, they are very simple. In such condition, it is not required to apply this particular micro motion study. Wherever the maximum time is required to perform the operation, small, I am discussing about only small movements. While performing the small operation, if that method is taking the maximum time, or while performing the small operation, if it is taking the maximum fatigue to that particular operator, in such conditions only we have to apply this micro motion study concept. So the first step is filming the operation to be studied. We have to select that method for which we have to go for the analysis. Once the analysis is over, means all the recording videos are available with you, all the timings are available with you, at that time we have to go for the analysis of data. And in that particular analysis of data, it includes film is running slowly. Film is running slowly. So due to that particular slow motion, so whatever the small movements are taking place, in order to go for the analysis of that particular small movements, we have to run that particular film in very slow speed, and it is usually stopped and reversed frequently. If I have to stop that particular film, the provision should be provided. We can stop that particular video. We can observe the things. If I have to take that particular film or video in the reverse direction, the separate button is provided for the reverse direction. Again, we can go for the reverse direction. Again, we can observe the same activity. That means again and again, we can see that particular video, we can see that particular movement, and from that, we can go for the analysis of data and identify the motions. And the third technique is the making recording of the data. Recording of the data is done using the SIMO charts. So whatever the data we have recorded from this particular micro motion study concept, if I have to represent that particular data in the graphical form or in the form of tabular form, so that data can be recorded by using one of the chart. That particular chart is called as a SIMO chart. So we have studied one of the chart, maybe multiple activity chart. What that multiple activity chart represents, so whatever the movement is taking place by the left hand and whatever the movement is taking place by the right hand, or whatever the movements are taking place by the operator, or whatever the movements are taking place by the machine, both the movements can be recorded on the single chart only. The movements of the operator and the movements of the machine, whether that machine is idle or working, or whether that operator is idle or working. It can be recorded by using one of the charts on single chart only. That chart is called as a multiple activity chart. Similarly, in case of a micro motion study, whatever the activities we are recording by using the camera, it is called as a motion picture, or in short, it is called as a videos. Whatever the small videos we are recording by using the camera, and whatever the timing we have calculated by using this particular micro chronometer, each and every activity we are measuring, time required for each and every activity we are measuring, that timing or that particular movements, it can be recorded by using one of the charts. That particular chart is called as a SIMO chart. So SIMO chart is one of the chart which is used for the proper representation of the activities performed during the micro motion study concept. So that we will see afterwards, but just now here it is mentioned that the third technique is that whatever the recordings we have carried out, whatever the timings we have measured, all that particular recordings or all that particular timings, it can be represented by using one of the chart, and that particular chart is called as a SIMO chart, which is called as a simultaneous motion operation chart. What is the long form of that particular SIMO chart? Simultaneous, it represents SI, and MO represents the motion. Simultaneous motion cycle chart or simultaneous motion charts. So through this particular chart, we can represent all the small activities performed during the operation, and in order to perform that particular activity, what is the time required? So that can be represented by using this particular SIMO chart. And now from this particular two methods, you can easily get the information. What is the use of the micro motion study? So here the two figures are represented. The first figure is applicable for the old method, and the second figure is applicable for the improved method. So in the old method, we can observe that whatever this particular white lines are representing, that white line represents the movement taking place by the operator while performing the operation. That particular white lines are present, then white dots are present. That particular white lines, this particular white lines, it represents the movement taking place by that particular operator during the operation. And you can see how many times repetitive movements are taking place. At this particular location, repetitive movements are there. At this location, repetitive movements are there. Here also repetitive movements are there. Here also repetitive movements are there. Here also repetitive movements are there. So such types of the small activities which is repeated in the single machine only. But here we have not applied any concept. This is the old method. But afterwards, I will go for the analysis of this particular old method, and whatever the repetitive operations are taking place, that all the repetitive operations I can eliminate it, and I will improve that particular method. And if you look at to the picture of the improved method, in that particular improved method, in very less time, the repetitive movements are taking place. You can compare both the figures. In the first figure, that white line represents number of white lines are there. That white line represents again and again that repetitive movements are taking place. But afterwards, I have go for the detailed analysis. I have eliminated all the unnecessary operations, all the repetitive operations. Then I have developed that particular method. And if I will implement that particular developed method in the same machine, and if you think about the second figure, in that particular second figure, in very less quantity, that white lines are available. If we compare the figure number 1 and figure number 2, in figure number 1 or in the old method, maximum white lines are there, means this is the old method in which maximum repetitive movements are taking place. But in case of a improved method, as this method is called as an improved method, very less repetitive movements are taking place, and it can be represented by using the same, that particular white lines. So this is the use of the micro motion study concept. So in the older method, if operator is performing the operation by using the camera, we can record all the techniques. By using the timing devices, we can measure all the types of times. Okay. So if this old method is taking the 1 hour to convert the raw material into the finished goods, again I will go for the detailed analysis. Repetitive operations I have eliminated, unnecessary operations I have eliminated. Whatever the fatigues are taking place, that fatigues are eliminated. And after that, whatever the improved method I got, now that improved method is taking the time only 45 minutes. Older method is taking the time 1 hour. Improved method is taking the time 45 minutes. That means 15 minutes are reduced to perform the same operations. But in order to reduce that particular 15 minutes, initially we have to go for its recording in the form of camera, recording of the time required to perform that particular operation. Afterwards, we have to go for the analysis. Through that particular analysis, eliminate all the unnecessary operations, eliminate all the unnecessary movements, eliminate all the repetitive operations, then develop the new method, implement that particular new method on the same machine or for the same operation. Again, use the camera. And from that particular camera, you will get the modified figure. So if you compare the figure number 1 or the figure number 2, from that particular comparison also, you will get the information about how the method is improved from the old one. So this is the use of the micro motion study, which is used to track the small movement, but we have to divide that particular activity into number of activities, and analysis of each and every activity can be carried out by recording the motion picture and the time required for that. And that particular, all the information, whatever you will get from the micro motion study concept, that information can be represented by using one of the chart. That chart is called as a SIMO chart. That is simultaneous motion chart. So that simultaneous motion charts we will discuss in the next lecture. So with this, today we will stop here. The remaining part we will see in the next lecture.